the second part of the task is to have a go at using Circuit Wizard. First thing we need to do, create a new project. Well, that's really easy. You can click that thing, or you can do File, New, like that. It makes no difference. And the important thing though is you need to create an electronic circuit with Genie flowchart. Now, in fact, we're not going to use the Genie flowchart. You could equally well use Genie Basic, but don't worry about why. Okay, just go for this one, circuit with Genie flowchart. And so now it gives us this blank page here. Now we want to build a circuit with a 6-volt battery, single pole, single throw switch. Now, if you don't know what an SPS switch is, it's basically just a regular everyday switch. It's going to look something like that. And that's the circuit symbol. Okay, single pole, single throw. The pole, you could think of the pole being like the hinge, and then the throw, it like the throws it is either on or it's off. So it's off, or it's open, so it's closed there, and then it's open. Okay, so that's the type of switch I'm talking about. And we're going to have a lamp bulb as well. So let's get the battery. That's in power supplies. By the way, if you ever accidentally close this panel on the right, you can just get it open there. It's called the gallery. So let's just get a battery. Well, we said 6 volts. Let's double click it. Let's change that to 6. Let's just zoom. I can zoom in and out with the wheel on the mouse. Now, normally, actually, I'd be using this program full screen, or at least, maximize the window. I'm just trying to split the screen here so I can view the web page as well at the same time. So up to you how you work. Okay, we've got a battery. You need a switch. So you just click this drop down thing here, and then you're looking at input components, switches, or you can just go to input components. But then you get like a larger list. If you want to narrow it down a bit, you can go input component switches like that. Single pole, single throw, like so. By the way, if you want to rotate components, you can do it like that. You can also press Control R to rotate clockwise. Really useful knowing that. So Control R for rotate clockwise, Control L for rotate anti-clockwise, or leftways, I suppose they were thinking when they thought of L. Okay, so we've got the switch, and then we also want the lamp. Now notice I haven't actually made any connections yet. Normally I tend not, so I like to place the components first, but don't have to do it like that. So we want a lamp. Now a lamp is an output component, so you could choose that very broad category, and actually I can see them there. Or if you wanted, you can narrow it down like illumination. And you've got 2 types of lamp there. There's no real effective difference here. Let's just drag in a signal lamp. And now I'm going to just connect them up. So I just click on it and just drag around. Now, if you make a mistake, you can just click on it and then press delete. There's also a delete thing there, okay, but I tend not to use it. I just hit delete on the keyboard. That's delete rather than backspace. And then so I go like that. And sometimes you're going to make a mess. You're going to go like that. So you don't want to do it like that, do you? You can, if you want, you can try and clean it up. You're probably better off just click it and just delete like so. At the moment we haven't checked the lamp. Let's double click the lamp and you'll see that it is a 6 volt 60 milliamp lamp. So if you put 6 volts across it, because the voltage is across the component, it will draw 60 milliamps of current. Now if you don't know too much about what current and volts are at the moment, don't worry, you're going to be learning more about that when we do the core. And now to test this out, we can just click run. And then obviously the lamp, or maybe not obviously, but the lamp is not illuminating because the switch is in its open state. So we can click it and then the lamp illuminates. So we've done that, simulated a circuit, checked it worked as expected. Well, that's exactly what I would expect. And now have a go with different view styles. So these view styles are the things down here. Okay, so sometimes these are quite useful. Logic levels will be very useful at times. At the moment, probably doesn't make a lot of sense with a light bulb, although you might like to try and play around with those. Never use those myself at all. The useful one is probably, or one of the useful ones is current flow. So at the moment, you see there's no current, but if we close that switch, that's quite nice actually. That's quite helpful to a lot of people to see the current flow. And normal view is obviously it's the default view. Actually, if you're going to do screenshots and the like, I recommend using standard. That's a better one. You can stop and start here. By the way, you can't make changes if you pause. So if you try and pause and then try to change stuff, it doesn't work. You've got to stop. Let's start again. And if you hover over a wire, you can see, you can check voltages. You can also check current. Okay, so next part then is to duplicate the circuit and add another lamp. So we need to stop the simulation, and I'm just going to select like that. Now I could, if I wanted, right click, choose copy, and then I could choose paste. Now personally I never do it like that. I'm more likely than not just going to select, and then I press and hold the control key on the keyboard and then drag and then drop like so. Okay, that's the way I like to work. If I don't do it that way, then I'm more likely to choose Control C and then Control V to paste, and then I just click where I want it to go. So you use your own method. I do like using Control Drag because then it's very easy to like Control Drag like that to make a copy, but it's up to you. So we duplicated the circuit, add another lamp. I just did that so that the two lamps are in parallel. Well, they're not connected at the moment, so let's just make them in parallel. So let's just go back to the first circuit. If you remember, there was 6 volts across it. That was the source voltage, and 60 milliamps. So you might guess then what the current is going to flow through here. Well, let's just have a quick look. Oh, sure enough, that's 60 milliamps. And that's 60 milliamps. So can you guess how much current is flowing through the switch? Well, if we hover over it, or hover just before it or after it, you'll see it's 120 milliamps. Let's just stop this. It then says add a text box next to each circuit and add a note about the voltages and currents. Now I'm not expecting a lot here. What I would like you to do is to add a text box. You can go Project, Author, Text Box. You've now you've nearly completed, well, you have actually completed all the required parts for task 2. I told you it would be easy. There's some optional tasks. Try adding some voltmeters and ammeters to the circuit. You can find those in test instruments. Now, so let's just take up full screen. So if you go down to the bottom, go to test instruments, and we've got ammeters and we've got voltmeters. Now, let's just get rid of that. Now, a voltmeter is always used across the part of the circuit where you want to take the voltage measurement. So I've just put it across or in parallel with bulb 1, lamp 1. And now when I run, in fact it's not very clear because it's too close. Let's go a little bit further. You'll see that it tells me that there's 6 volts there, which is of course the same voltage as the supply voltage. You might be interested in doing something like this. Let's do Control L to rotate it. And would you like to guess? Now, remember this is an optional task, and it doesn't matter if you do this or not, but would you like to guess what that voltage will be when we run the simulation? Well, it's 60 microvolts. It's more or less 0, okay? Now, this switch has a resistance, therefore it has some voltage drop. Maybe this will make more sense to you later as we go on in the course. But when we open this switch, you'll now see, and this is perhaps unexpected to you, that now we've got the full voltage across this open switch. Now, we'll talk much more about that at a later date, okay? So don't worry about that too much at the moment. We've also got this ammeter. Now, the ammeter must always be used in series with the circuit, with the components. It has a very low resistance. So, for example, if you, and wrongly, do not do this now, if you try to do this, the current, rather than, let's get rid of this, the current, rather than going through the light bulb, would go through the much lower resistance of the ammeter, and the ammeter would most likely blow up, or at least fail. Okay, so never do that. What you need to do is, in fact, let's not delete that. Let's just cut it and place it over here for the moment. If you want to measure current, then current must be measured in series. Doesn't matter where, it can be before or after your component. So let's put it around here. Notice I tend to use keyboard shortcuts, rotating. Remember Control R to rotate clockwise. And now no current, 0 amps, and as you might expect, 60 milliamps. And what you could also do, you could rearrange the circuit to have ammeter come from maybe the battery or returning to the battery. You could have an ammeter in each branch of this circuit as well. You could also enable explosions. Now, yeah, not being funny about this, but this is always very popular with a certain type of student. Don't spend all day on it, okay? But if you want to try it, then you can go Project, Simulation, Explosions. Now, hopefully at the moment, we're not going to have anything blow up. And no, we didn't have anything blow up. But say if we changed this voltage, by the way, I had to control, at the moment it's simulation stopped, but I wanted to open switch, so I did a control click. Now, if say I change this to something ridiculous like 6 kilovolts, okay, and these bulbs, remember these were only 6-volt bulbs, and when I then run this, let's see what happens, and sure enough, yeah, switch blows up, as do the bulbs, okay. Don't try that one at home. Do save your work. Saving your work is simple. You just click that, save it somewhere where you're not going to lose it. I recommend giving it a useful name. And you've now completed tasks 1 and task 2. I told you it would be quick. Task 3, the Common Core is going to be significantly longer.